The line "Big Bang never happened" has been going quite viral on the internet for some time now, meaning the Big Bang never actually took place. Do you also feel something like this? So let's learn about a theory that didn't just suddenly come into existence out of nowhere. The Big Bang theory that we see today has taken decades to reach this point, evolving from an idea, going through a lot of evidence, physical and mathematical proofs. This theory has traveled a long journey, and during this journey, we found many things that can only be explained by the Big Bang theory and not by any other logic. And there are also some things that directly and indirectly prove the Big Bang theory itself. We are going to discuss all these things in detail in this video. So first, let me introduce you to the person who started all this. Eric J. Lerner, who is so desperate to prove the Big Bang theory wrong that he has even forgotten the difference between a theory and a hypothesis. And besides that, he is also quite frustrated with the entire scientific community that accepts the Big Bang theory as correct, because that community doesn't give enough attention to his illogical ideas. Actually, he has been speaking against the Big Bang for quite some time, but the current controversy is because of one of his articles which he published on the website of the Institute of Arts and Ideas. So let's see what the truth is behind this claim and take a look at this article. The headline is "The Big Bang Didn't Happen. What do the James Webb images really show?" It was written on July 11, 2022. Below is Eric J. Lerner, obviously the writer of this article. And look at this, President and Chief Scientist of L Fusion. He is the author of "The Big Bang Never Happened." The Big Bang never happened. Lawrenceville Plasma Physics Fusion is also a project of Eric J. Lerner, in which he claims that he can make fusion reactions possible with a machine that can fit in a small storeroom. And the way he will carry out that reaction, there will be no nuclear waste produced. Today, major countries around the world are spending billions of dollars on technologies like tokamak for nuclear fusion, while Eric claims he can achieve the same fusion reaction for just $90 lakh. By the way, whatever Eric says about the Big Bang, whatever his views are, he is still a reputed scientist. He has written many papers on plasma reactions, and moreover, he has even received funding from National Aeronautics and Space Administration for his Lawrenceville Plasma Physics project. Anyway, if his claims about fusion technology are correct, then he is really doing a great job for science. But now you need to pay attention to the articles published on his website. Two articles published on July 5th. The first is "Censored Papers Demolish the Dub. Big Bang Hypothesis," in which he has literally given evidence to demolish the Big Bang. Now you can tell how frustrated he is with the Big Bang theory just by his wording. Also, he has called the Big Bang theory the Big Bang hypothesis. We will come to that too. But first, the thing to note is that when Eric submitted his papers to archive.org, his papers were censored, and there is a special reason behind this as well. The points he presented to disprove the Big Bang theory have already been refuted by many scientists, meaning they have already been proven wrong many times before. But he is a bit stubborn. He just doesn't stop his actions, so this had to be done. However, we will also discuss what those points of his are. His second article on this website is "Scientists Protest Censorship in Cosmology." Actually, Archive refused to publish research papers of two of his colleagues along with him, which were raising questions about the validity of the Big Bang. So in response to that, he gathered a total of 24 physicists and astronomers from 10 countries and organized an online protest, or you could say signed an online petition against this step taken by Archive. Now, Eric is literally quoting wrong things just to prove the Big Bang theory wrong and is trying to create an atmosphere of confusion in the entire scientific community. So here, the step taken by archive.org also seems right, but he believes that this behavior is being shown towards him because he spoke against the Big Bang theory. Now, whether that's right or wrong, I'll leave that up to you, but before forming any opinion, do make sure to watch this video till the end. And all the references being mentioned here, you'll find the links to all of them in the description or in the pinned comment. So that was about their website. Now let's talk about the book published by them. Because look, whatever I'm showing you here, these are very important things. These are quite interconnected with each other and will help you a lot in reaching a final conclusion. Eric published a book in 1991 called "The Big Bang Never Happened." Now just think for yourself. A person publishes a book called The Big Bang Never Happened. And when all over the world people start discussing that the Big Bang theory is succeeding day by day, so that person would obviously feel a bit frustrated, and maybe that's the frustration we're seeing now. And it's possible that the success of the Big Bang theory has hurt his ego, because if nature itself is presenting such strong evidence against someone who made such strong claims against the Big Bang theory, then maybe panic has increased a bit too much in his life. And yes, one more thing, if there's no hype around Big Bang Never Happened, then his books will become useless, right? And then how will they sell? So everyone needs hype, brother.
The real crisis in cosmology is that, as I wrote back in 1991 in my book, The Big Bang Never Happened.
So let's move a little further in this article now. The Big Bang hypothesis. I mean, there's something off in every line of his. He's so agitated that he can't even tell the difference between a theory and a hypothesis. So let's first understand the difference between a theory and a hypothesis. Because man, we don't want the next Eric to be one of us, and seriously, we also don't want any of your concepts to remain unclear. So it's written here. Whoever it is, now a hypothesis is any guess or assumption that is made before conducting any research. Now, why do we make assumptions or guesses? The answer is that we need to test or prove certain things. And apart from this, we use hypotheses to set some limits or to achieve a certain optimum range or result. Whereas a theory is something or a principle that proves what is visible in your data, a theory is based on conclusions drawn from observations and evidence. Now, the example for this is quite simple, and I know that you will really like this example. Now, suppose you have never traveled from Delhi to Agra, meaning you don't have any data regarding this. So now, if you want to make this journey by bike, you will form a hypothesis about how much time this journey will take, what the bike's mileage is, accordingly, how much it will cost, and apart from this, you will have to plan a lot of other things as well. First of all, you did some guesswork, which is the main part of a hypothesis. Now you have come to a certain result that it will take this much time and this much expense will be incurred. So here, do you need to test the results you have, or do you need to prove them right? Now, why did you use a hypothesis? To set a certain limit, like if this journey can be completed in 20-25 liters, then there's no need to spend money on 100 liters. So we get this limit from the hypothesis itself, and this hypothesis will later become a theory. When you have data available to prove your assumptions, and that data matches your assumptions, or your assumptions prove that data, suppose at that moment, a friend of yours comes and says that he has already made this journey before, and the time and cost values you have calculated are absolutely correct. Then your hypothesis will turn into a theory. So I hope you have understood the meaning of hypothesis and theory. But here, Mr. Eric should understand that cosmic microwave background radiation, that is, cosmic microwave background radiation, is just like that friend of yours who told you that the values you calculated are absolutely correct. That means the values and results of the cosmic microwave background radiation can only be explained by the Big Bang. That means it's an evidence that proves the Big Bang theory, and it can only be explained by the Big Bang theory. So how can we consider the Big Bang as just a hypothesis? Right now, we're not even talking about whether the Big Bang happened or not. First, let's just accept that the Big Bang is a theory. It's not just an assumption, a guess, or a hypothesis. Besides, cosmic microwave background radiation is not the only evidence that supports the Big Bang theory. In fact, there are many things like the expanding universe, redshift, Hubble constant, dark energy, and many others that support the Big Bang theory. It has also been validated by numerous experiments and observations. January 1st, 1925 was the date when we humans made the greatest discovery of this universe. This was the date when the great cosmologist Sir Edwin Hubble revealed that not only the Milky Way is not the only galaxy in this universe, but there are many other galaxies like it that exist as well. The collective group of these galaxies forms our universe. This one theory shook the entire world of astronomy, because after this, the expanding universe hypothesis and the Big Bang theory came into the picture. And before anyone realized it, the way humans viewed this universe completely changed. They were able to consider not just our galaxy, but also nearby galaxies and their objects. Meanwhile, when Sir Edwin Hubble observed distant ones, when he noticed the pattern of the galaxies, he found that the recessional velocity of these galaxies and their distance from our Earth are directly proportional. In simple words, the farther these galaxies are from us, the faster they are moving away. This rule of astronomy was named Hubble's law. Although this rule seems very simple and easy, it actually contains a very big mystery of this universe within itself. At the same time, the Hubble constant, which is obtained by solving this equation, has also become a big headache for scientists. In such a situation, the question arises, what exactly does the observation of the Hubble telescope want to tell us about the stars of the universe? And what are we misunderstanding about our universe? Well, we will debunk all these myths of space science. So stay with us till the very end of this journey in today's episode, because by the end of this video, you will have encountered the secret gateway to the biggest mystery of this universe. So let's begin this journey. In the past, whenever scientists tried to determine Hubble's constant, every time a new and puzzling number would come up, which made this puzzle even more complicated instead of solving it. Because of this, we still haven't been able to solve the biggest cosmological mystery so far, but efforts are still ongoing. Even today, many astronomers and scientists are working to calculate it. So, away from all this, to get to the bottom of this matter, first it's important to know what exactly this constant tells us. After all, what difference will it make if we find out the value of this Hubble constant? Let's find out. If we look closely at this equation, we'll find that there are two different entities here. The first is the recessional velocity of these galaxies, and the second entity is the distance between these galaxies. And this equation expresses the mathematical relation between these two entities. According to this equation, if we calculate the recessional velocity of galaxies in kilometers per second and the distance in megaparsecs, the resulting value will come out in the unit of kilometers per second per megaparsec. To understand this better, suppose the value of the Hubble constant is 100 kilometers per second per megaparsec. This would mean that for every megaparsec of distance, a galaxy will acquire an additional recessional velocity of 100 kilometers per second. This also mathematically proves that as galaxies move farther away, their speed keeps increasing. This same Hubble constant is denoted as h0 in the language of physics. This number plays a very important role in the world of cosmology because through it, all forms of the universe from the Big Bang until now can be understood. This is the number that can provide us with solutions to all the mysteries related to the universe. So then, what is the problem that our scientists have failed every time in calculating it? And even today, almost 100 years after this discovery, this mystery remains unsolved. Well, the answer to this question is actually hidden within the question itself. Actually, to calculate the value of the Hubble constant, we need two things. First, the recessional velocity of that galaxy, meaning the speed at which it is moving forward in space, and second, the distance of that galaxy with respect to Earth. To calculate the recessional velocity of any galaxy, we observe the wavelength shift of the spectral waves coming from there, which is also known as the cosmological shift. Tracking this is very easy and simple, so there is no problem at this point. But the second parameter of this equation, distance, has always been a problem for us. There is a standard procedure to calculate the distance of any galaxy, which is to study their safety variables. In simple terms, this is the method where the difference in light is related to mathematical time to determine the distance. Almost this same process is used to measure the distance of any star or galaxy. In this process, the distances are determined based on the calculations of the luminous gaps of any body. When you look at the graph, at first the luminosity appears to decrease, then after a certain point, it starts increasing again. Astronomers conducted this study on several parts of the universe and calculated observation values from there, which were then further compared to the visibility of those same objects from Earth. And after this equational study, finally that distance was found out. And after all these scientific observations and calculations, Sir Edwin Hubble calculated the value of the Hubble constant as 500 kilometers per second per megaparsec. To obtain this value, he found out the distances and recessional velocities of 46 different galaxies and equated them, after which he was able to reach this final conclusion. By Edwin Hubble, the value that was calculated is 7 times higher than the value considered by modern science today. But the problem here is that we can use the Cepheid method only for objects that are within a distance of 1 kiloparsec to 50 megaparsecs. That means for galaxies that are beyond a distance of 50 megaparsecs, this value will not be valid, and we won't be able to observe them using this Hubble constant. If we need accurate information beyond that, then something even more precise than this is required. And this is where Type 1a supernova enters the story. A Type 1a supernova is a binary system in which a gigantic white dwarf collides with a companion star, creating a hypercluster of energy. And in the end, when it explodes, it radiates extremely intense light rays. With their help, we are able to further increase our understanding of universal distances. Using these explosion impacts, we can see much farther than 50 megaparsecs. To study these very supernovas, the Hubble Space Telescope will conduct the supernova H0 for the equation of state of dark energy mission, which stands for supernova H0 for the equation of state of dark energy. Under this, by studying these supernova explosions, references will be created, and using them, gigantic distances will be calculated and the Hubble constant will be determined. Recently, the Hubble supernova H0 for the equation of state of dark energy report that came out in 2019 claimed the value of the Hubble constant to be 74 kilometers per second per megaparsec, whereas an elite team of scientists studying the universe rejected this report in their study and gave a different value, which was 6742 miles per second per megaparsec, much lower than Hubble's value. However, Team Hubble did not give up here. After this, they observed Hubble's 10,000 orbits and around 10 supernova explosion track reports to obtain a new value, which was 73 plus 0.62 miles per second per megaparsec, which was still much higher than the value measured by scientists, but this value was also verifying Hubble's 2019 calculations. Therefore, even today, there is still uncertainty about this value of the Hubble constant. We are still confused and doubtful about its actual value. By the way, what do you think? Will National Aeronautics and Space Administration's flagship telescope, James Webb Space Telescope, be able to solve this mystery? Be sure to share your opinion with us in the comment section. We humans want to go to Mars, and plans for this are already in place. If we want to land our astronauts on Mars, we will have to study the microastronauts. Yes, you heard it right, our microastronauts. That means the bacteria that already live in our orbital observatories in space. Our astronauts never travel alone in space. Every astronaut carries about 100 trillion bacteria viruses and various types of microorganisms on their body with them into space. Many of these are essential for humans, while some are extremely dangerous. But we still haven't understood how these bacteria react in microgravity and space. And the most dangerous thing is that we still don't know how many types of bacteria live on our International Space Station. But National Aeronautics and Space Administration now wants to find this out. Recently, astronauts have collected samples from almost every corner of the International Space Station. It's kind of like conducting a census of those microbial astronauts so that we can understand them, and if they are dangerous, we can eliminate them or stop them. So that no sci-fi movie-like incident can happen on the International Space Station hundreds of kilometers above. Or if there are long-duration missions like going to Mars, then how should we deal with them? Bacteria are always around us. It is believed that there are as many bacteria on and inside our body as there are human cells inside us. You can consider humans as a moving ecosystem because of them. Scientists believe that most of these bacteria are actually essential for us, and they have a deep impact on our health. They affect our immunity, our heart, and even our mental health. Scientists often see this microbiome as an invisible organ that collectively works for our body. That's why it's no surprise that for long-term spaceflight missions like going to Mars or even farther, studying and understanding this invisible organ is extremely important. Scientists are not only concerned about the human microbiome, but the spacecraft also has its own microbiome. In 1998, on the Russian space station Mir, about 3 years before it deorbited into the Pacific Ocean, scientists found dozens of species of bacteria there that we had never even imagined. They were hiding behind the service panel. At that time, scientists observed this microbiome working on the space station like a beautiful machine. That microbiome was something alive, just like a human's. And sometimes it can turn out to be dangerous for the astronaut's health. Just imagine that you and your companions are going on a long journey to Neptune, and suddenly you find out that there's a bacterium on your spacecraft that eats flesh. So how will you deal with that invisible enemy? And this isn't just some crazy idea. In 2006, a team of scientists sent samples of Salmonella bacteria on the Space Shuttle Atlantis for 11 days, just to find out that when the bacteria returned to Earth, it would kill mice much more easily. And it is believed that the bacteria that live in space are not affected much, which is even more dangerous. These will weaken the astronauts' immune systems during long journeys in space. Now that we understand that bacteria are very important for any space mission, it becomes even more important to understand them. That's why, to reduce and completely deal with any such microbial threat, National Aeronautics and Space Administration's Jet Propulsion Laboratory has launched a project. In February 2024, astronaut Kate Rubins collected samples of bacteria from about 100 places on the International Space Station. They were kept in cold storage for a few months and then sent to Earth, where scientists will study their genetic signatures and name them. And a three-dimensional map of these microbes will be prepared, meaning the entire microbiome of the International Space Station will be studied. It will be observed what types of bacteria can be found in which locations. Scientists currently know very little about which molecules are present on the International Space Station that are supporting the growth of bacteria there. This map can tell us which molecule is associated with which microbe and how it is promoting the growth of the microbial community. As soon as we know this, we can promote the growth of beneficial bacteria and reduce the growth of harmful bacteria, and that too just by controlling the amount of molecules or nutrients. With this, we can find out about very long journeys. For example, to go to Mars, which materials should be used in the interior of the spacecraft. With this, we can protect our spacecraft from getting contaminated even before our astronauts. Kasturi Bentesh Renjo, who is a senior biologist at National Aeronautics and Space Administration, says that right now we have to send samples back to Earth. But they can still be studied there, although the process won't be fast and we will have to deal with this hassle soon. Mali, the thing is that when we go to another planet, we won't have the option to send samples back to Earth, nor will we have that much time. Because in any dangerous breakout, every moment is precious, and we have already seen this very well during the COVID-19 pandemic. How can a tiny virus cause such devastation across the whole world? The samples that Rubin has collected include two types of samples. One sample is of microbes, while the other sample is of their metabolites, meaning the natural chemical byproducts of those microorganisms. This will allow us to link the microbes with their metabolites. And when we have this data, we can create small biosensors that will be able to detect these metabolites. You can imagine a device that you can hold in your hand to detect the presence of bacteria or fungi on a spacecraft. It will be just like a carbon monoxide detector, although such detectors will become a reality in the next 10 to 15 years, allowing for immediate action to be taken. To prevent any outbreak, cleanliness can be maintained at specific locations. This way, we will be able to make our future habitats safer. A lot of effort is made to keep the population of these microbiomes under control on the space station. Every week, the International Space Station is thoroughly cleaned to prevent any such outbreak. Every astronaut on the International Space Station spends about 3 hours a week just on cleaning, which means that 6 astronauts spend about 18 hours every week cleaning the International Space Station. If you look at it, that's quite a lot. But the conditions on the International Space Station are completely different, where sanitization is very important. Because if you drop any kind of food on the space station, it doesn't fall to the floor like it does on Earth. It can go go anywhere. It can stick to the ceiling, to the walls, meaning it can be anywhere. Some scientists believe that such a microbiome outbreak is not a major threat to us on long interstellar missions or Mars missions. Their argument is that we have been living on the International Space Station for the past 2 decades, but we haven't seen anything like that there so far. Finding a dangerous bacterium is not necessarily a warning sign. We should only be worried if that bacterium starts making astronauts sick. We shouldn't end up killing the good bacteria around us out of fear of an outbreak. That's why this decision should be made very carefully. We should observe how different bacteria react in a stressful environment and make decisions based on that. That's one reason some people worry about the harm these bacteria could cause to astronauts and the spacecraft. At the same time, there's also concern that we might accidentally wipe them out by taking them to another world. When our astronauts travel to other worlds, that means bacteria from Earth will also reach those planets with them. So there's always a fear that those bacteria might contaminate that planet. Because of this, we might get false positive signs of life on other planets. And that's why National Aeronautics and Space Administration and other space agencies take a serious approach on this issue. That's why National Aeronautics and Space Administration crashed its Cassini-Huygens spacecraft into Saturn so that no contamination could reach its moons, where there is still a strong possibility of life existing anyway. The thing is, our astronauts themselves act like pathogens for other planets. The astronauts who will set foot on Mars for the first time, they will have their own unique microbiome, and even the spacesuit they wear will have its own microbiome. If scientists are able to map that microbiome, they will be able to choose a better material for that suit and also clean it more effectively. Apart from this, scientists can also design a better spacesuit from which fewer microbes leak onto another planet. Apart from this, the benefits of studying this subject do not end here. Even though this research is happening in space, its applications range from space travel to Mars colonization. But even here on Earth, in our homes, airplanes, and hospitals, every place has its own microbiome. Just as we can prevent some microbes from growing in space, we can do the same here on Earth as well. For example, tests are being conducted on the efficiency of an antimicrobial coating on the International Space Station, which was developed by Boeing. The idea is that if this coating can work in space, which is much more dangerous than Earth, then it will easily work here on Earth as well. Often, space technology makes our everyday lives much easier, but for now, by understanding these bacteria, we can take our space travel to the next level. Loneliness is truly dangerous, that condition where you can't see anyone for miles around. There's no one to talk to, no one to help, and you're badly entangled in the circumstances. Just the thought is scary that if suddenly every human disappeared from this earth, if only you were left behind, that loneliness would eat you up from inside. And maybe in that eternal loneliness, you would even start talking to the silence. You would be alone in your house, in your city, in your country, and even on this earth plunging into this dreadful darkness, you would be alone. What scares us even more is that we still haven't found any neighbors in this universe. And we still feel this loneliness on a cosmic scale even today. This whole scenario becomes even scarier then, when you realize that no matter what you do, you can't stop that coming loneliness. It will happen anyway. And something like this is happening in our universe. Our universe is constantly disappearing, and with every moment, we are becoming more alone in this infinite universe. And in the coming time, there will be a moment when, even if we want to, we won't be able to reach even the nearest star. Even if we travel at the speed of light, knowing all this, we still can't do anything. We can only watch as this universe makes us powerless, imposing countless natural laws like the speed of light on us, making us alone. Today's video will narrate the story of our universe for billions of years to come, and in my opinion, this video goes beyond our present time. It's just to forget everything and bring some deep thoughts to your mind. It's to understand how this universe actually works, and maybe this is a question we've been searching for centuries. So let's begin today as well. You can close your eyes if you want. Your imagination will make this video even better. It's been almost a century since we found out that our universe is expanding. By the way, the story behind the expanding universe is quite big, but we all know that Edwin Hubble proved this by studying the redshift of galaxies moving away, that in the universe we live in, things are moving away from each other. But the truth of the expanding universe wasn't limited to just this. In fact, the reality was that the farther a galaxy is from us, the faster it is moving away from us. This was a frightening thought for all those who imagined a future human civilization that would rule the entire universe. When there will be no galaxies visible far away in the universe, only a dark sky and not a single star will be seen in the sky, then where will that advanced civilization rule? And this very question was scaring all of them. Many times people make mistakes in understanding this theory of the expanding universe. Their argument is that if the universe is really expanding, if stars and galaxies are moving away from each other, then how can our neighboring galaxy Andromeda collide with us? So here we need to understand this theory, which says that galaxies are not physically moving away from each other. Rather, the space between the galaxies is expanding. The objects in this universe that are gravitationally bound will not be affected by this. But the part of space where there is nothing for a long distance, when the fabric of space expands there, its effect can be seen. The theory of the universe's expansion was proven only a few years ago, but by then, we already knew that as time and distance keep increasing, this expansion of space will also keep increasing continuously and just as rapidly. A galaxy that is moving away from us today will get even farther from us after some time. Because of this, it will move away from us even faster, and this will keep happening. Eventually, a time will come when it will go so far beyond our reach that even thinking about reaching it will be out of the question. We won't even be able to catch the light coming from there, and that galaxy will disappear from our view in this infinite universe. The space between that galaxy and our galaxy will start expanding faster than the speed of light, because of which we will never be able to see that galaxy again. And believe me, the universe is disappearing like this, and there's nothing we can do about it. When you look up at the sky and see a star whose light took about 100 years to reach you, it means that star is 100 light years away. And the reason for this is that the speed of light has a limit. It can only travel the distance of 1 light year in 1 year. But when you are looking at the light coming from a galaxy, which has traveled for about 100 million years to reach you, so it doesn't mean that the galaxy is 100 million light years away from us. If you do the calculation here, it will turn out to be wrong. Actually, that galaxy will be much farther away than this. The reason is that when we talk about smaller scales, things are often gravitationally bound. Stars come together to form clusters, and billions of stars come together to form a galaxy, which are gravitationally bound to each other in a very strong way. But if we talk about very large scales, gravity's binding is not as strong there. The light that travels from there to reach us takes a lot of time, and during this time, the expansion of space also does its work. The light that reaches us is also affected by the expansion of space. That means, along with space, the wavelength of light also gets stretched. And the more time that light takes to reach us, in that much time the galaxy gets even farther away from us, because that galaxy is not gravitationally bound to us. We call this the cosmic redshift. If light is being emitted from somewhere, it has a particular energy and a particular wavelength, and we expect that when that light reaches us, it should have that same particular wavelength. And this would have been possible if the universe was not expanding, but in reality, that never happens. The farther a galaxy is, the more redshifted the light coming from it appears to us. Now we know that the universe is expanding and will continue to do so. But with this information, we can find out how the universe has evolved over time and what exactly the universe is made of. Scientists studied the light coming from distant regions of the universe. Based on their distance, redshift, their actual size and apparent size, their actual brightness and apparent brightness, the entire expansion history of the universe was recreated, and it was also determined what kind of energy and matter are present in this universe. This entire universe is made up of 68% dark energy, 27% dark matter, 4.9% normal matter, 0.1% neutrinos and antineutrinos, and about 0.008% photons. And when we came to to know the components of this universe so precisely, the law of gravity was applied to them, and Einstein's general theory of relativity brought forth a dark chapter of this universe before us. First, these laws were applied to the dark energy dominating universe, and the results we got were astonishing. First of all, the galaxies that are not gravitationally bound to us will eventually disappear one by one. They will keep moving away from us faster and faster, and the space between them will keep expanding more and more rapidly. And this led us to a conclusion that is even more disturbing. This means that a time will come when, after reaching a particular distance, the expansion of space, because of which a photon that left our galaxy towards another galaxy or is coming from that galaxy to our galaxy, it will never be able to reach us, nor will it reach them. It will just keep running in the fabric of this infinitely expanding universe, keep running, but it will never be able to reach anywhere, because space will be expanding at a speed much faster than that photon's speed. It's like he's running on a treadmill, but he won't be able to reach anywhere. If this thing can trap even one like this, then we humans aren't even at 10% of the speed of light yet. But just think about it, if we set out on an intergalactic journey and got trapped in such an expanding space illusion, we would keep wandering there for eternity. We would never be able to reach the other side, nor would we ever be able to return home. This is truly nothing less than a terrifying nightmare. At that time, even this space would seem no less than a black hole to you. The only difference is that here you would be able to struggle. You would get time to stay alive, but you would never be able to get out of here. If we talk about the present, the radius of our observable universe is about 46 billion light years, and that magical distance, meaning the reachable limit, is only 18 billion light years. You might be really shocked to hear that already 94% of the observable universe is out of our reach, and only 6% of the observable universe is within our reach. If there is a galaxy at the edge of that, then if we set out to explore it today, we can reach there. And even then, we would have to travel at the speed of light, otherwise that too would disappear from this universe just like that. This means that every second about 20,000 to 60,000 stars are moving out of our reach. The light that left those stars this second will eventually reach us one day. But the light that leaves that star at the edge in the next second will never be able to reach us. This thing feels scary to us. It's creepy, it's disturbing, and it brings a different kind of thoughts to our mind. But we can also think about this in a positive way, that the universe wants to tell us that every single second of life is very, very precious. If we want to do intergalactic travel, if we want to go beyond our local group, then we have very little time. Every single second, 60,000 stars are disappearing from our reach, places where we might be able to go. The more we delay, the more opportunities we will miss. There are about 2 trillion galaxies in the observable universe, and out of those, 94% have already moved beyond our reach. The remaining 6% is also continuously decreasing. Another way to look at this is that no matter how big our universe is, only a small part of it, the observable universe, is available to us, which we can see and observe. And even within this, we can only reach 6% of it, so what's the use of such a universe where we can't even go? This raises a lot of questions in our minds. Are these limitations being set by the universe itself, or is there someone else stopping us from exploring this universe? And what if we don't develop intergalactic travel soon? To get out of our local group, the entire human civilization will be confined to just our local group. The whole universe will slip out of its hands like sand, all the other galaxies will slowly disappear from sight, and the sky without stars will look completely dark, scary, and strange. Many questions come to mind. Sometimes it feels like, why is there a speed of light limit after all? Can't we do anything about it? Will we always remain trapped like this? Yes, of course these questions don't really matter to us, because it's a long process that takes billions of years. We won't be able to see any of this happen. But it's these very questions that have brought our science this far today. What are your questions about this universe, and can we prevent the loneliness of this universe? Be sure to share your opinions with us in the comment section. I hope you liked today's video. If you enjoyed it, please like it and be sure to share it with your friends. For more informative videos like this, make sure to subscribe to the channel and enable the bell notification. Friends, we'll meet again soon with another new informative video. Until then, stay curious, be happy, and goodbye.